Have you ever just, found yourself staring up at the night sky, feeling that sense of wonder,
Hmm.
that huge sparkling darkness above us? It just stretches out forever, and for so many of us, that feeling, it sparks this dream, right?
Yeah.
To see those incredible, vibrant images of nebulae and galaxies, the kind of stuff you see online all the
It's
time.
in James Webb photos, yeah.
Yeah.
Or even just TikTok sometimes.
Mm.
Amazing shots.
Exactly. But okay, let's unpack this a bit because here's the challenge, and it's a pretty big one.
It is.
There's this huge gap, often a really disheartening gap, between those amazing digital processed images
Mhm.
and what you as a beginner are actually going to see through your very first telescope.
It's a massive gap. We sometimes call it the two skies.
The two skies.
Yeah.
Yeah.
So on one side, you've got that breathtaking, colorful digital universe.
Mm.
Fancy equipment, long exposures, lots of computer processing.
Mm.
And then there's the other sky, the one you actually see at the eyepiece. And it's subtle. It's quiet. And it's overwhelmingly black and white or maybe shades of gray
So like the Orion Nebula picture you saw online, all pink and purple.
through your scope. It's probably going to look like a ghostly, maybe gray-green mist. Still amazing, but different.
And Andromeda, that big spiral galaxy.
Just a faint, fuzzy smudge, usually, a little oval glow. This expectation gap, it's honestly the biggest reason newcomers get disappointed.
I can see why.
And it makes sense. Years ago, beginners maybe saw magazine photos or drawings, which were actually much closer to the real view. Now, you see these incredible HD images first, and it sets this impossible standard for your eye. You feel underwhelmed.
Yeah, that sounds rough.
But, and this is important, we need to kind of reframe what seeing really means here.
Okay.
It's not like looking at a finished photograph. It's not passive. It's an active thing, an immersive process of discovery. The real thrill isn't just seeing a pretty picture instantly. It's the hunt for that faint fuzzy. And then the realization, the really profound thing, is that the light hitting your eye, it's traveled for millions, maybe billions of years just to reach you.
Wow.
That connection, that personal link to the cosmos,
Mm.
no photo can give you that. Not really.
Okay, so if you're listening and you're dreaming of space, but maybe worried about that potential letdown, this deep dive is definitely for you.
Mhm.
Our mission today is to bridge that gap. We're going to walk you through choosing a really capable first telescope, something under $500.
Yep, totally possible.
We'll talk honestly about what you can realistically expect to see, and crucially, we'll share the skills you need, the actual techniques, to unlock the universe with your own eyes. It's about shifting your perspective, really, embracing the journey, and learning the art of seeing.
Exactly. Learning to see.
All right, let's dive in. First things first, a common idea beginners have. Bigger magnification means better views, right? I need like 500x zoom. Is that the main thing?
Oh boy, that's the classic trap. Almost everyone thinks that initially.
Right.
But the actual golden rule for telescopes is aperture, not magnification.
Aperture, okay.
Yeah. Your telescope's main job isn't zooming in. It's gathering light. And the aperture that's just the diameter of its main lens or mirror, that's the most critical number.
Why aperture?
Well, two reasons. It dictates how much light it gathers,
Uh-huh.
which lets you see faint things. And it dictates its resolving power, how much fine detail you can actually make out.
I see.
So those cheap scopes bragging about 500x, 600x magnification, it's mostly just misleading marketing.
Because it's not real.
Well, technically they can magnify that much, but it's not useful magnification.
Yeah.
Anything beyond, say, 50 or 60 times per inch of aperture just becomes a big, dim, blurry mess.
Ugh.
And honestly, most nights, the limit isn't even the scope, it's the Earth's atmosphere. That turbulence, as astronomers call it, seeing, usually limits you to maybe 250x, 300x max, even with a big scope, before the view just turns to mush.
That's a really important point. So, light gathering in detail, driven by aperture. Okay, so even with that, under $500 budget, are there genuinely good options, or is it all compromise?
No, absolutely. There are some fantastic choices if you know what you're looking for. We've kind of picked out three main types, three workhorses for beginners under $500. Each gives a slightly different experience. It's like choosing your adventure path.
Okay, lay on us. What's the first path?
First up, the Dobsonian Advantage. For just pure visual bang for your buck, these are the champs. Unbeatable, really.
Dobsonian. Okay, what is it?
It's basically a simple, sturdy wooden box mount, an alt-azimuth mount, holding a big Newtonian reflector tube. We call them light buckets.
Light bucket. I like that.
Yeah. Their secret is simplicity and just raw light-gathering power. Super intuitive, too. You just point and look. A 6-inch or even better, an 8-inch model will give you just breathtaking views of the moon, the planets, and you can start resolving details in brighter deep sky stuff. It's amazing for the price.
Any specific recommendations?
A great example is the Skywatcher Heritage 150p. It's a 6-inch tabletop Dobsonian. The tube even collapses for portability, often around $350. Fantastic visual scope.
Nice. Okay, option 2.
Option 2 leverages your phone. Smartphone-assisted scopes. This is the push-to revolution. Think about the biggest headache for beginners.
Finding things.
Exactly, finding those faint fuzzies. So scopes like Celestron's StarSense Explorer series tackle this head-on. You put your phone in a dock on the scope.
Mm-hmm.
The app uses your phone's camera to look at the stars. It figures out the pattern. That's called plate solving, so it knows exactly where the scope is pointing.
Wow.
Then, the app shows you arrows on screen, guiding you to manually push the telescopes right to your target. It solves that initial frustration.
That sounds really helpful.
It is.
Yeah.
The StarSense Explorer DX130AZ, that's a 5.1-inch model, often around $500, is a great example. Just remember, it's still manual, you do the pushing.
Yeah.
And sometimes the tripods aren't quite as rock solid as a Dobsonian base.
Gotcha. And the third way?
The third way is the new wave. Smart telescopes. Things like the ZWO C-Star S50 or the Dwarf Lab Dwarf 3. These are often around or maybe just under $500.
Okay, smart telescopes. What's the catch?
Here's the big difference. These are basically small, robotic astrophotography platforms. They are not visual telescopes like the others.
No eyepiece.
Exactly. No eyepiece. You control everything with an app on your phone or tablet. You pick a target, tap go, and the scope finds it, takes long exposure images, and stacks them together in real time to build up a color picture right there on your screen.
Whoa, so it directly solves the "it doesn't look like the pictures" problem.
Precisely. It's a super accessible way into astrophotography, but it's a totally different experience. You're looking at a processed image on a screen, not, the actual photons hitting your eye directly.
3 really distinct paths then. Traditional viewing, guided manual, or straight to screen-based imaging. That's impressive choice for the budget. But, now the warnings. What are the landmines? The things that can just kill your enthusiasm.
All right, this is critical, because buying the wrong scope is worse than buying no scope at all. There are definite hobby killers out there.
Okay, number 1.
Number 1, hands down, is unstable mounts. A flimsy, wobbly tripod makes everything impossible. You can't keep the object centered, you can't focus properly, the slightest breeze or touch, and the view just vibrates like crazy. This is why those cheap all-in-one department store scopes are usually a terrible idea.
Avoid the department store specials. Got it. What else?
Flawed optics. Specifically, watch out for a design called a Bird-Jones Newtonian. They use cheap spherical mirrors with a little extra lens stuck inside to fix it. The problem is, they're incredibly hard to align properly, and they almost never give a sharp image. Just pure frustration.
Any models to name and shame?
Well, the Celestron Power Seeker 127EQ is a very common example that experienced astronomers strongly advise against. It embodies these issues.
Okay, unstable mounts, dodgy optics. Anything else?
Yeah, worthless accessories. Cheap scopes often come bundled with really poor quality eyepieces. Like they'll throw in a 4mm eyepiece that gives crazy high magnification, but it's totally unusable, dim and blurry, or flimsy plastic Barlow lenses that actually make the view worse. You're better off starting with 1 or 2 decent eyepieces than a whole box of junk.
Okay, so you've navigated the pitfalls, you've picked a good scope, that's step 1 done. But before you dash outside, let's manage those expectations again. What will you actually see? Because like you said, the views are subtle, need patience, but offer that unique connection.
Exactly. Managing expectations is key to enjoying the journey. And let's start with the easy wins, the wow targets. Our celestial neighbors, the moon and the planets. These guys are reliable, impressive, and they even cut through a fair bit of city light pollution.
So start in the solar system. Makes sense. The moon.
Oh, the moon is spectacular, seriously. In any telescope, it's not just a flat disk, it's a whole world. The absolute best views are along the terminator, that's the line between lunar day and night.
The shadow line.
Right. The low sun angle there creates these incredible long shadows. Craters look deep, mountains stand out. You can see the texture of the Maria, those dark lava plains. Pro tip, a full moon is actually kind of boring visually, too bright and washed out. Crescent and quarter phases are way better for detail.
Good tip. Okay, planets. Jupiter.
Jupiter's fantastic. It's dynamic. Even in a small scope, you'll easily spot its 4 largest moons, the Galilean moons. They look like tiny, bright stars lined up next to it, and their positions change noticeably night after night.
Cool.
The planet itself, you'll see it's a small, distinct disk. And you should clearly see its two main dark cloud bands, the equatorial belts. On a night with really steady air